There is no AI without data, and there is no data without databases. It is common to talk about database management systems as a tool to power up AI applications, but less common to talk about AI powering up your database management system. But that's precisely what Mohamed Nsiri will talk about in the next session. Mohamed is a senior product manager at Canonical, and he will explore how AI can benefit your database management system with concrete examples from the Postgres ecosystem. Mohamed, take it away.
Thanks for joining, everyone. So today I'm going to talk to you about AI and databases. We are going to start by explaining how databases can support your AI projects and why actually you have an interest in making sure that your AI tasks run as close as possible to your databases. Then we will show some demos, and then we will speak about how AI might improve your database management systems, and then we will finish with some conclusions. So let's start. So data, actually AI is about data, and generally speaking, a lot of data, and databases can help you store those data, whether we are talking about raw or metadata, whether we are talking about features, so basically the pre-processed data that you are going to use in order to train your models, for example, or embeddings, which here we mean by basically the output of your model. And databases can allow you to store large volume of those data. The next thing that we can use a database for in the context of AI is making transformation within the database itself. So of course you can create pipelines to take the data from one area or one data solution to another and do the processing or the transformation in those pipelines. But it can be as well better to perform the pre-processing within the database itself in order to minimize the amount of data and therefore the resulting cost that you need in order to run those pipelines. So this can happen in two ways. Either you use the SQL capability, which is like the de facto standard for most databases these days, and you can as well use some Python packages that would run in the database directly, and we will see some database that can allow you that in the next slide. And databases are as well great tools to perform all sorts of search on your data, whether it is full text search, which is quite important for natural language processing, or vector and similarity based search. And some of the databases like MariaDB and Postgres now support vector search within the database directly. You can as well perform all actually the machine learning related steps within the database directly by performing the training of your models within the database and as well serve your models from within the database, as we will see in the next slide, where we will take Postgres as an example. So Postgres obviously allow you to store all sort of data, but it has as well some specific extension that allows you to handle more efficiently specific data types like geospatial data with PostGIS and PG routing. And if you are in a case of time series data, like when you are having a lot of sensor data or something like that that are for which we have always a timestamp, then using a timescale DB extension can help you perform efficiently several query on those data. So Postgres actually ships with a default procedural language that we call PGSQL here, and it can allow you already to, with something like cron extension, it can allow you to perform the transformation of your raw data within the database itself. But it supports actually, so here we're talking about Postgres, a lot of other procedural languages, including Python, and it can allow you as well to run some Python library in the database directly, which is something that I think you should always try to do or consider at least, because it allows you to do all your transformation locally without leaving the database and saving a lot of cost in the process and time. Yeah. The other thing that Postgres can do for you is to perform specific search optimization depending on the nature of your data. So as you might know already, Postgres is the a very capable database when it comes to full source. There are a lot of extensions. I'm not mentioning all of them here, but pgtrigram, dict-based search, and so on are some of the extensions I think that you need to look for. And more recently, we have now an extension called PgVector, for which we are going to have a demo in a few slides that allows you to perform similarity search, in your data. And some extension and framework did push the idea even further, like PostgreSQL and Madlib, and both they allow you to train actually your models within the database directly. And basically with PostgreSQL you can have all the steps that and all kind of tasks that you need for an AI typical AI project to run within the database. So let's now talk about why actually you have an interest in shifting as many AI tasks as possible to your database management solution. In my opinion, this can be helpful to quickly iterate on your AI idea without investing in a big infrastructure just to experiment with a few ideas before basically going to production, and there probably you will need a more full-fledged solution as we offer with Kubeflow at Canonical. It can allow you as well to simplify your stack and therefore simplify its adoption by your teams, but as well by your end users. And in some cases, it can actually help you to get better performances. For example, by reducing significantly the amount of data transfers that you need to do from one data store, where typically you store your raw data, to another data store where you are going to store processed data. So now we are going to have a demo, and we will start by basically setting up the scene with having some prerequisites. So those instructions that you see in the screen should run on top of any Ubuntu system. So first we start by installing LXD, which is a powerful manager for system containers and virtual machines. We will initialize LXD next, and then we will create a VM that we are going to use as our playground. We connect to the VM, we make sure that all the packages are up to date, and then we go to the next step, which is installing Postgres. And thanks to Ubuntu, installing Postgres is a one-step story. Everything, all what you need is actually just to type sudo apt install Postgres, and you have a working database that you can connect to, as we are showing in the next line. And then you can start issuing queries. And here we are going to check the available extension. And if you install Postgres 16, as we are doing here, you should see one line which corresponds to the default procedural language that we talked about. Then we are going to quit the console and install PgVector, which we do support not only as a dev package, as we are showing here, but as well as part of the container image that we do provide for Postgres that contains a number of supported and maintained extension. We actually have more than around 100 now already, including the built-in extension of Postgres that are already supported and highly integrated in one container image, but as well in one snap image. So we install the PgVector deb. We connect to PSQL again. We create a database that we call embedding. We connect to that database, and then we create extension. You can think of this as activating the extension. And now if you select again from the PG extension view, you should see another line corresponding to the PgVector extension. Now we are going to create a user, because we should always avoid using the super user that we were using before, which is the Postgres super user, as much as possible. And we do that by running the first command. Then we alter the database embedding that we previously created to make demo the new user its owner, so that all the objects that we're going to create are owned by that user. We set role demo, meaning we switch to this user, and we create a PgVector table that contains an embedding column that has vector as a type, which is added by the PgVector extension. You can think about it as just like a list of arrays. Of course, we will create a primary key, an auto-generated one. Yeah. Then we are going to insert few values, as you can see in the PgVector table. and then we are going to perform some queries. So we are going to use the PgVector operator, so Euclidean distance, for which the operator is the one that you see, and we are going to sort the embedding value that we insert by their distance to the basically array 7, 11, 13. Okay, and you will see that when we change the operator to use the cosine distance, then you will see another like order. And you might ask, okay, this quite good, but how I can use it in a real world environment? So that's why we are going now to use PgVector in conjunction with OpenAI to see what you can do basically with that. So first thing that we are going to do is to delete all the data that we just inserted from PgVector because we are going to change the structure of the existing column, the embedding one, to extend it to 1536 as a size, as length of the vector, and we are going to add the column that we call document that will correspond basically to the text for which we are going to create embedding using the OpenAI client. Then we just display the PgVector table column just to make sure that everything runs fine. We create an index on PgVector using the HNSW algorithm. So PgVector ships with two algorithms. We are using this one because it's just faster to do so for a demo. And then we are going to quit the console again and install a few Python packages that we will need. So here basically what you need is just the OpenAPI package, and the second one is the one that we are going to use in order to connect to the database and interact with the database. Then the next step would be to create a very small, script, Python script. So after importing, what we need and having some variables that represent the model, the embedding model that we are going to use, and the GPT model that we are going to use, we have a list of lines that basically correspond to some text for which we are going to create embedding. So here I just have chosen some dummy examples where we have basically which Ubuntu version will ship with which Postgres version. So in 2404, as we have seen, we ship it Postgres 16. In 2504, we should ship Postgres 17, and 2604 we should ship Postgres 18, and so on. And then the last one is actually a question, for which we are going as well to request OpenAI to provide like an embedding, but we are going to use it, just as an example, because we are going to calculate the distance of this question to the other lines. So let's say, the documents that you would have inserted to your database, and using, let's say, the similarity search, we will see that, PgVector and Postgres will be able to give us the closest match to this question. And this is, of course, just a demo, but you can extend the idea to create, for example, your own search engine, local search engine in this case, for whatever document you would like to index, whether those PDF documents or your own website and so on. So let's see the next part of the script. So of course here we need to initialize the OpenAI client, and we do so by executing the first line. Of course, you need as well to have an OpenAI API key that we are supplying here as an environment variable. Then we are creating a list of embeddings, and we are contacting the OpenAPI in order to create embedding for every line that we did just show in the previous slide. And after doing that, we are going to create a batch which is consisting of the tuples of the embedding that were provided by OpenAI and the original line. And then here we are going to insert batch insert, which you should use, of course, to speed up your interaction with the database. So here we are creating the query that we are going to use. We are connecting to Postgres using the demo user and supplying the password that you did already use. We are going then to use a cursor to use, the execute values, which basically will batch insert, all the elements that we are supplying, and then we commit, and that's it. Basically, that's the end of the script. Then we can actually use the script to run the program, as you can see, Python 3, and the PgVector P, where basically I stored the script that we did just see together. After doing that, if you connect to the database, this time using the demo user and selecting, the number of elements in the PgVector table, you will see that we have 4. And now we are basically going to use, PgVector basically and Postgres as a way to search for the closest statement to the document or to the text what Postgres version Ubuntu 25.04 will ship. And by executing this query, we will see that, very quickly actually, and not only because we have few elements here, but even if you test with a lot of data, you will see that you have very decent performance with PgVector, and you will see that basically the closest statement, apart from the text itself, is in 2025 Ubuntu 25.04 might ship Postgres 17. And it's worth noting that PgVector does not support GPU acceleration today, but it supports for the x86 architecture, the AVX 512 instruction, which help, in speeding up your vector operation. This like we are doing here. And this actually, if you have like a CPU that supports those extensions, which should be the case for all the AMD CPU and for most of the enterprise, Intel CPU, then it should allow you to have, decent performance, at least for an experimentation with the capability or with some AI ideas. Yeah. And that was it for the demo. So now we are going to talk about rather how AI itself can improve database management systems. And we will go throughout, some ideas and some research papers that are basically discussing some interesting, ways of doing so. So first of all, before going into the idea and what can happen next, we are going just to explain basically how a database management system, at least a modern one, would look like, from internal model perspective. And here, if we follow the data flow, meaning, let's say that you are sending, a query to your, Postgres database or whatever, modern database, then most of the time you will see all those steps that you are showing here, as different stages of processing those queries. So of course there is the first step, which consists about basically managing the connection to the client. Then you will have a kind of task manager that will perform the admission control, and it will dispatch basically this request to whatever available resources the database might have. Then you will have a query processor that will parse and the query that you did send, perform authorization, and then will try to build a plan on how actually to execute, or what are the instructions that the database needs to execute to satisfy your query. Then we have an execution engine that will orchestrate the plan execution that was generated or computed by the previous step, and manage any replication or any orchestration that it might need to do with other instances. This is especially true if you are having like a sharded database. Then you will have a storage manager that will manage buffers, logs and transaction, and issue the correct reads and write to the storage layer in order to provide you the result that you requested. And of course, this is where the database layer ends, but there are of course other layers that the database interacts with, like the file system, the operating system, and the hardware. But we are not going to talk about any of that today in relation to AI. So the first idea that I think we might see quickly, because to some extent is already there for some commercial databases, is AI helping with optimizing the query processor stage by automatically suggesting and implementing better indexes to speed up your query, okay, using machine learning. So by the way, I mean, I just wanted to mention that you can actually do this manually already today. Like for Postgres, if we keep, taking Postgres as an example, using the extension that we provide here, you can do this yourself, meaning that you can, monitor the statement and the query that are executed for which there are no indexes, and using epoPG, which basically is about hypothetical indexes, check whether creating an index on the colons that are used by your query will help you speed up, your query, and by how much. But here we are talking about, using like a model that would automatically suggest and implement even indexes. And here is, like a paper that, if you are interested, you can read in order to learn, about how this can work. The other thing that AI might help with in regards to databases is to have purpose-built index structures. Okay, so I think most of database engineers and DBAs and people who are exposed to the database would know that the ubiquitous structure in database is the B-tree, and using ML, we think that we might be able to propose other, index structure that would speed up even further some of the queries. Yeah, and if you would like to learn more, I invite you as well to read this paper. And it's already a reality. I mean, today, using tools such as ChatGPT and so on, you can basically ask it to write SQL query for you. But it's important that, even if ChatGPT is able to do so, you will still be the one debugging those queries. So it's very important to make sure that you understand them and that you are sure that actually are performing, what you intend them to perform. And this is like a general statement, even if AI is, becoming more and more a commodity, what's even more important than using them is understanding actually, the output and how this is computing, and be aware about the limitation of those technologies. Another thing where I think AI can help a lot is the optimization of the storage manager, and specifically the buffer management strategy. So of course, how to manage a cache, and how to manage basically your RAM, the RAM that you are allocating to the database, has been an area of research for decades, literally, and we start to see that there are some people thinking about using again AI and machine learning in order to come up with better replacement cache, like page replacement strategy in the context of a database. Another area where we see like some research is using machine learning to fine tune the overall parameter of your databases. So if we take, for example, Postgres, we have something like more than 300 parameters already. And if we take some commercial databases, the number of parameters is probably like 10 times more. Yeah. So even a very experienced DBA sometimes will have hard time, like fine tuning every parameter alone. And I think using machine learning, because those parameters might depend on the hardware that you are using, might depend on the workload and so on. So I think using machine learning will help us having more sane defaults that are not just defaults like they are static, but as well they are dynamic, in the sense they take into account the hardware and the workload that you are using. And this is definitely is an area where AI might help with in regards to database management systems. So this was basically like an outlook at how AI can influence the database management landscape. And now we are going to finish with some conclusions. So first, we show how bringing AI closer to your databases can help you quickly iterate on your AI ideas without investing in a full infrastructure just for proof of concept. Simplify your stack and therefore its adoption by your teams and your end user. It can as well help you speed up basically the response time of the overall service, because you are doing less data transfer, and therefore from performance perspective it should be faster, but as well it should result in lower cost. Yeah, specifically depending on your cloud provider and your setup, you might be charged for the volume of data that you are transferring as well. And we did see as well how AI can bring to database management system and to database vendors and maintainers a lot of benefit. So it's not something I think we will see like, very quickly, but something definitely that can happen rather in midterm. Yeah. So something that we need to follow closely. So that was everything for today. Thank you for your time. If you need any help, with any database, open source database that we do support at Canonical, I invite you to check the link throughout this QR code, and hopefully you'll be able to help you in your AI and in your enterprise projects related to AI. Thank you, everyone, and have a good day.